first thing that comes to your mind when I say the word plastics? Water bottles, packaging, your phone case? Or you may be thinking of the millions of tons of plastic waste collecting in our landfills, heavily polluting our environment. Some of you may even be thinking of the thousands of sea turtles that wash ashore dead each year due to the plastic debris in our oceans. Let me tell you, 90% of all the commodity plastics that we use today are also derived from fossil fuels and are not biodegradable. All of these things make us feel very guilty as consumers. But I'm here today to tell you that this is not how it has to be going forward. I'm working on developing green nanobiocomposites that come from the soil and will eventually go back in it. These biocomposites that I'm fabricating are made up of a base polymer matrix of polyethylene. It's like the gravy of the composite. And instead of fossil fuels, it is derived 100% from ethanol that comes from a source like plant biomass. And before I go any further, let me explain to you what biocomposites really are. Biocomposites are a special class of engineered materials that are derived from a natural organic source and are either biodegradable or compostable. Most biocomposites use agricultural waste fibers such as wheat straw to reinforce the base matrix, what I call the gravy. This makes the material stronger, and we can use it as a green replacement for a bunch of different applications. The problem that arises, however, in this seemingly simple solution is that when we try to use too much of this fiber to make the material very high-performing, these fibers tend to stick together and form aggregates, negatively affecting the overall properties of the material. And that is where I come in. I'm using nanoparticles derived from starch to do two things. One, to fix this problem of dispersion, and two, to reinforce the material even more. Would you like to know why that works? Well, it seems like size really does matter. Because these nanoparticles are so small, and because technically speaking, there's true chemistry between these nanoparticles and the fiber surfaces, so we can manipulate these nanoparticles to help move around and disperse these larger fibers more evenly and more homogeneously in the base matrix. This leads eventually to a material that is both high-performing, and we can tailor its properties to fit a plethora of applications, all the way from disposable cutlery to agricultural mulches, construction, furniture, and even automobile parts. So the solution here is not to step away from plastics or to ban them, because they have led to the enormous progress we have seen in the past 100 years in the field of technology, transportation, agriculture, and so much more. The solution is to find opportunities of re-engineering that will make our materials more sustainable, like my new nanobiocomposite that is recyclable, renewable, biodegradable, and competitive. Thank you very much.